Let's see. All right, so I'm going to go ahead and get started on this section. So the PGLO lab. I know it's kind of a doozy. And I wanted to kind of explain what was happening on the submolecular level. So in terms of the PGLO lab, right, it's not really important that we focus on the negative PGLO. It was like it's supposed to be a negative control, right? So I'm going to go ahead and erase those plates. And I'm going to explain to you why you see the lac operon. So the lac operon is an inducible operon. It's similar and functions very similarly to the PGLO operon. Okay. So if you were ever to be asked a question like, other than the lac operon, what is another type of inducible operon? You can say PGLO because you know it. Or what's an example of a repressible operon? It's the exact opposite of inducible. What is the three-letter word you said up here? The what operon? Would be the repressible operon example.
TRP.
Yes. And do you know what that stands for? It's okay if you don't.
Tryptophan?
Tryptophan, yes.
Tryptophan.
It's what we have, what's in turkeys, right? That's what we eat, makes us sleepy. Okay, so to focus more on the inducible operon side, I'm going to show you what's going on in each of these plates. So right now, we have our LB amp plate, right? So keep hitting that. Let me adjust this to the side real quick. So our LB amp plate, this is what's kind of going on inside. Okay. So we have our just kind of normal state. This is the lac operon is technically repressed. Okay. So I'm gonna kind of draw it. 3 prime. This is our 5 prime, right? So we have this regulatory gene in here, right? Regulatory. This is our regulatory gene. It has repressor mRNA. Okay. And this thing is getting continuously made. Okay. Cellular repressor mRNA being constantly. Okay, this is what's keeping our operon completely repressed. There's nothing stopping it. It's being transcripted or translated and transcribed all the time, right? The gene goes from transcription, repressor MNR, translation, and makes this repressor, right? So I'm gonna do that really quickly. So transcription, and then from the RNA is translation. I hope that I can maybe, I'll bring it a little bit. we're gonna get up close and personal. Right? Transcription, mRNA translation. And now what we get is this little repressor. Okay. So this repressor is now going to go to the promoter region. Okay, this is going to be our promoter. It's going to go up here and it's going to bind on, right? It's going to bind on, and that way our DNA polymerase can't. So this the DNA polymerase was late to the party. DNA polymerase is sad. Look at him. He's so sad. He can't bind. He can't bind on. He cry. But you see, now that we don't have anything being translated anymore, or transcribed, that means that the things that we make, right, the 1, 2, 3 that you see, these are genes that allow us to break down lactose, okay, in this example. So in the lactose example, so in the pGLO example, right, we have the repressor mRNA constantly going. The repressor's here, DP wants to bind on, but it can't. And these genes right here, so this is allowing for us to produce our glow. These genes code for bioluminescence. But the thing is, the DNA polymerase isn't binding, and the DNA polymerase isn't binding. So the bioluminescence genes aren't being expressed. Okay? This is what's happening in this plate. Okay? Because right now there's nothing to bind to this repressor. Now, if we were on this plate over here, does everybody get the repressor aspect? This is how it is normally. There's nothing really stopping it, or there's nothing really inducing it. It's just kind of sitting there, right? Just kind of how it normally would be. It's just you on your couch. Okay, so to move over here, let me guys over there. I'm gonna stand up. Actually, I'm not. I'm getting a chair. So for this one, for the positive pGLO, the difference in these two are the arabinose. We established that, right? So our arabinose sugar is going to induce our operand, right? I said 3 prime. How much room do I have? I guess I have that much room. Yeah, 3 prime to 5 prime, right? This is our regulatory gene. The regulatory gene, right? It's going to be transcription. Going to be continuous all the time. So it makes our repressor mRNA, and then it makes translation quicker, which gives us our repressor, right? But this time, in this plate, we have the arabinose sugar, which is going to come in, right? So our ARA is going to come in and form a complex with this repressor. So now we have the repressor and the inducer combined. So now this complex that's happening here, it's changed its shape and its function compared to just how the normal repressor looks. So remember how we had that promoter region? Now this can't bind anymore. So now when our DP comes in, it's gonna be so happy. So happy. How do I make him happier? Still happier. That's just kind of creepy, but anyways, He's gonna be so happy because now he can bind. He can bind. Now our DP3 can bind. He's bound. He's bound now. And now he can go and make these genes for fluorescence. Now we glow. That's why we glow, right? Now we glow. I'm gonna try to get this guy down here. So obviously he's coming in. So does this make sense? So all because we have the arabinose sugar, it labels our, here, so we have arabinose sugar. Now our repressor is useless. It can't bind. So it's just gonna go out here and be stupid. Because it's lame for not wanting us to glow. So it's gonna be out here. And our DNA polymerase is gonna just have a ball just continually doing this as so long as the arabinose sugar is there to, because remember this is continuous. Even if this is continuous, as long as there's arabinose sugar for every one that this one decides to pump out, the arabinose can come in and match it. Okay. So as long as there's continual translation and continuous support of arabinose, then there's going to be continuous translation of the glowing gene, the P glow gene. This is inducible. This is induced. Now let's say the arabinose runs out, right? No more here. That means all of a sudden there's going to be something produced here, right? What's going to be produced here, remember, because this is continual, no more era, which means that we're going to have one that cannot be bound to it, arabinose. So now we have a working repressor. It's going to go back here and we're going to return to that original repressed state. That's when the arabinose sugar runs out. Okay, so these are off and on all the time. It just depends on what is there. Okay, so does this make sense about what's going on? Cool, I'm glad. This is what messes up people a lot, and it's really unfortunate because it's pretty simple when you just kind of break it down, right? You guys will want to know the lap operon as well as the trip operon. It just kind of functions the reverse. So yeah. But anywho, yeah. Is there any questions you guys have for me about future labs, this lab, any other labs? Somebody said that they had a question for me about lab 11 earlier. Oh, it was about the multiple choice. Okay, yeah, we can talk about it. Let's go ahead. Okay, let's see.
So my question, you guys be quiet. My question is number one. I just think that I didn't know if I should circle A because the wording, it says under regular light, both transformed and non-transformed bacteria appear the different. Should that say the same?
I'm pretty sure she said appear, just assume it's different. If it says different, it's different. I know it's a weird typo, just cross out the and it makes sense, kind of. So remember how did we see this in lab? How did we see the glow in lab?
They look the same under regular light.
Yes, they did. So
Don't circle A.
don't
Right?
circle it. No.
Got it.
It's that UV light that allowed us to see the difference. But yeah, I'm sorry, I couldn't open your like thing. I don't know what it is. Oh wait, oh, I saw it for a second. It says video extension is required to display this image. So I was like, oh, okay. I don't know what that is, but okay. But yeah. Are there any other questions you guys might have? I'm going to, by the way, I know this is a big expectation for you guys, but I hope after the end of next week, you have at least maybe half of the antimicrobials memorized. So what's going to wind up happening is you guys will see your results and then start on that last page, which is matching about what its modes of actions are. The Quizlets will help you with that. But my main, like, I really, really urge you guys to try to do the matching activity first and look up the answers. I know the headache and the time it takes, it is almost not worth it, but in the end, you're going to be like, oh my God, like, you know, I'm never going to forget that this is this, right? So if you do that and you look them up and you make a good effort to try to answer I want to say it's lab 13, 12, 13 or 12. If you try to answer the, you know, the multiple choice or not multiple choice, the matching, if you try to answer the matching on your own for the antimicrobials, then I promise it'll do you good. And then use the Quizlets to study and reinforce. Okay. I'm giving you this as a small treat so that you guys, you know, can study it. But do not, because I did derive it from I know for a fact I did derive the Quizlets because I made them from that last page. So if you get stuck, you can use it as a resource, but try to look for your information in your textbook. It might be there, but most preferably in your lecture and elsewhere in your lab. Okay. Maybe even try to use your results that you get as information as to what it targets. But that's why I'm trying to give you guys these resources to solidify what it is. Because there's a test mode on Quizlet. You can use it as a template to make your own flashcards. Anything you'd like to do works for me. You'll see that I'm sending 2 because I made them twice. It helped me to make 2 Quizlets of the same material to help reinforce it. Okay. Dr. B will get really mad at me if you cheat off my Quizlets, so please, please don't. Okay. Happy early birthday, Merry Christmas. What else do you get? Happy late Valentine's Day. This is my gift to you guys, okay? But do you guys have any other questions? Anything else you need me to know, ask? Remember, tomorrow, or not tomorrow, Wednesday. Wednesday will be the next review session. No problem. Wednesday will be the next review session, and we'll go over probably studying for the next quiz. Then we'll probably study for the next quiz then, but also probably some antimicrobials. I like antimicrobials. They're fun. They're just hard to memorize. But yeah, we'll go over quite a bit and prep you guys. Okay. For right now, focus on submitting the labs that are due soon. Focus on your case study. Case study is what you need to know for now. Well, this is not what you need to know, but what you need to work on right now is case studies. It's going to creep up on you, and then all of a sudden it's going to be the day before and you're still scrambling to finish it. Try to finish it now And then a couple days before you have to present, reread it and then be ready. Okay, that's a big word of advice because you have another big project creeping up on you. That's going to be your micro and your unknown projects. Both big projects. So get this one out of the way. And it's going to be more in depth than just case study 1. If you try to just copy and paste it over, you're going to get a lower grade. I promise you that. So try to be more in depth. Try to, like, for example, if the lab results say his white blood cell counts were this much, then you say the patient's white blood cell count was this. This is what the normal range is. This higher count of white blood cells is indicative of an infection. Cite the source, right? That's kind of the process that you need to do, is like, what information am I given? What does it tell me? And then, or like, what information am I given? How can I compare it to other information? What does that tell me? That kind of process. If you do that, then there's a good chance that you'll have a good amount of detail, and that also preps you for the granularity you need in that unknown project. The unknown project is a doozy, and I'll show you guys mine. Okay, so there won't be like nowhere to start, but go ahead and get a head start. Get as much work as you can done now. But yeah, that's my big pieces of advice. And I'll send out those Quizlets tonight, okay? So you guys are free to go. No problem. You guys are free to go and enjoy the rest of your night and continue to work hard, okay? Bye, guys. No problem.